Hello, I just wanted to apologize first for the glitchy computer and perhaps a little bit of the noise. But yeah, the point of this video was I wanted to show you this website, story.data.vercel.app, that you can use to draw your own data set just from the web. There's no need to use Jupyter Colab notebooks for this, okay? If you do it through this site. So what you have here is a blank canvas. You can change the color of the canvas, but we'll keep it black, right? And now, of course, we can draw, the way that we draw points is by just clicking on the canvas and then pressing on our mouse. But we can change the brush size for the points that we draw here, right? So you can see that this is an intermediate brush size. You can increase it to the maximum and you'll get way larger coverage. And you can see that as we draw, it updates all that information in real time. It generates the tabulated data for it. Okay. Right now we only have one feature, and the feature is called feature one. But we can change it we can change it by changing the text on this text box. We'll just clear it. We can change it. I don't know. We'll change it to white because that was the first color. We can get rid of that starlight or the trailing shading that we have there that was gray, right? By unchecking the starlight function. The starlight condition, right? And then we can add more features as well. We can add as many features as we'd like with that button, okay? And we can change the color of the feature that we add. This one is red, right? So we can change the feature label. That one was called white. So yeah, we can by adding, we can change also the brush size to smaller for red. Maybe we want to make it the largest but cover the least amount of space per area of the brush, so we can just decrease the coverage. If we want to maximize the coverage, we go all the way, and you can see that now it's very dense, right? So these are very, very helpful, I guess, features that our app has. We also track the state of all the generated points, so we can basically undo all the way backward and forward as well if we make any mistakes. We can also clear all that information, and as I mentioned, we can even change the name of the columns here for X, Y, and the feature name. We can change it. I don't know. We'll change location X, or location 1, location 2, and feature, I'll just call it object. Okay. And I guess I'll just draw a simple example here that we can use for classification as well. Okay. So in my example, we'll change white to web, spider web. Red, we'll just change it to spider. And of course we can change the color here. So we'll change that feature to green, and then flies. We'll have fly. A fly would be yellow. Okay. And now we can draw here on our canvas. Yeah, I guess I'll keep the background. Let's change the background to gray. Okay. And now the web, because it's white, will go all the way to the smallest brush size, slightly smallest, and highest coverage, and it will just be a concentric series of concentric circles here. Oops, not that concentric. Okay. That's it. That's gonna be the web, spider web. Sure, if you wanna make it more like a spider web, why not? Like this, right? Okay. Now the spider is gonna be the highest brush size. Well, moderately large brush size and large coverage, and that's our spider. Okay. That thing is gonna be our spider now. Now for the flies, we're gonna make clusters of them. They make them smaller than the spider, the clusters. There'll be clusters here that are supposed to be inside the web. And let's make more dispersed, sparse clusters outside of the spider web. Basically minimize the coverage by increasing the brush size. And those will be the flies here, right? They will be here all the way outside. Okay, and that's it. That's our data set. Okay, And now we want to export our data set. So we click on that button. Okay. Okay, we click on that button, and now we have it in comma separated value format. Now what we're going to do is we're going to run some machine learning inference or classification for our data set that we just created. Okay, of course, yeah, I forgot to mention there's also export PDF, but the graph is not that nice, right? But anyways, yeah, so we want to run classification for this. So how do we do that? There's this static script I developed by clicking on that link under many options. It will take you to this repo. And in this repo, what you can do is you can click clone. You can git clone that repository in your computer. Okay, so that's what we'll do. Git clone and the repo. And this repo mainly just contains one script, which is called script.py. And that script, what it does is it plots a decision boundary. It plots a decision boundary from your exported CSV file. Okay, and what does that mean exactly, right? So it takes your CSV as an input, processes it as a data frame, then after it processes it, prepares for classification, taking it, the X matrix is just the X, Y coordinates, and the Y variable here is the label, which in this case is the object, could be web, spider, or fly. It passes that information as inputs depending on also the classifier that you use, and this classifier just fits the classifier, so it trains, quote unquote, the classifier, and then the trained or fitted version is the output to that function, which is the classifier. This trained or fitted model then is sent to that last function, which plots the decision boundary along with the data. Okay, and all these functions here, if you want to, I guess like study them a little bit more, what they exactly do, they're above, right? This is a little bit more of a modular approach for programming, so it's helpful because it splits things into nice little components. All right, so basically what we have here also then it's, we develop some frameworks so that we can run arguments on the terminal. Okay, and that's what I'll show you now. So after you clone it with git clone, you get that script that I just explained to you. And we also have here a sample CSV file that we haven't exported. It just comes with a repo, okay? But we don't need it because we'll just delete it because it's not the one that we generated. We are interested in the one that we just exported. So what we do is we will go first to our newly cloned repo, and then we're gonna copy the exported file from the downloads directory. I believe it was called, Throne points. Okay, and now what we'll do is if you check, if you write Python script -h, it's basically a flag that shows you all the options that you have to choose from. You'll see that default file is called drawn points CSV, which is the file that we just copied into our repo. So we will basically load that file. -c is the type of classifier. It defaults as logistic regression, so we don't need to write -c if we want to do logistic. Otherwise, if we want to do decision tree, use a decision tree model, we have to specify it. And then save file, which I'll show you later. So now let's just run Python script, okay? So now you'll see that the classification with logistic regression is not that great. The decision boundary here is just doing a boundary in this place, which makes little sense, really. It's not separating the categories the way we want it to. So maybe it's better if we use a different classifier, right? What if we use decision tree instead of logistic regression? So to do that, we just type the flag for decision tree, and we run it again. And now you can see that we get better results, right? We get more refined boundaries, decision boundaries between the spider, flies, and the web. We can also, because it's this on Python on your terminal, you can also zoom in and to get a closer look, or even like print it here, right? On the decision boundaries as they get closer to the fly or the spiders, or here, right? How granular we could go, how high in resolution we could go for that decision boundary. But yeah, so now as you can see, it's also written the labels that we gave it on the CSV on the CSV file, even the axis, right? As you might remember it was location 1, location 2. If we go back to this drawing, right, those are the column names that we specified, that we gave it for the export. And of course object is not shown there because it's actually on the classification, but it was here, right? Yeah. So what we can do is we can also save this whole thing as a file, and to save it as a file we just run the same thing, but we write the flag, the -s, which is the save file flag, and we'll just call it graph.pdf. So when we run that, it will not display on your terminal. It will just give you a message, and then it saves it on that repo, or where you run the Python script, okay, which is on the repo for our case. So you can see that now this is on PDF format, and PDF format is actually for Python this is just a vector graphic, really. So what's great about it is that it's scale invariant. You can go zoom in very high, and it will basically retain that resolution. It's not pixelated or anything like that, and it's awesome because you can even use it for publications and put it on your reports, right, with LaTeX, and of course you can also select text, right? So with that being said and developed, I wanted to thank you for watching the video. I hope that you find my repo and website useful and helpful. Like I mentioned, there's no need really to use Jupyter Notebooks to draw your data. If you use this tool, right? A couple of things also I do want, however, to acknowledge. Some people acknowledge the open source project Draw Data, which was an inspiration for the development of this site. And it's also in the about. Well, buy me a coffee also if you want to. If you'd like to acknowledge also this work, and yeah, and subscribe to my channel as well if you'd like to see more awesome content. Thank you.